Good evening, everybody. Slightly different event to what we're normally used to, but I'll try my best to get you through the next 25 minutes and give you a good education into the business that I co-founded at the very end of 2010, the beginning of 2011, called Versarien PLC. Our business is all about taking IP from UK universities and turning it into products we can use on a day-to-day basis. At the moment, most of my work and that of my team is around exploiting graphene, the wonder material that was kind of isolated in 2013. Sorry, 2004, 2005. Let me just try and pull up a video.
Versarien is a pioneer at the forefront of advanced materials innovation, leveraging intellectual property from the leading universities of Cambridge and Manchester. These materials enrich products made by blue chips and small corporate entrepreneurs. Floated on the London Stock Exchange in 2013, Versarien PLC is blazing a trail of materials science engineering. Based in the Graphene Engineering Innovation Centre at the University of Manchester and the Cambridge Graphene Centre, our teams have helped collaboration partners to design, test and manufacture commercially viable products. In 2014, Versarien acquired a spin-out enterprise from the University of Manchester to help it scale up production of high-quality 2D materials. A few years later, the company then successfully acquired a separate business from the University of Cambridge to strategically scale up production of graphene inks. Our global expansion has progressed rapidly, with our business making inroads into North America, South Korea, India, and Japan. And significant links have been established between the People's Republic of China and Versarien, supported by the UK Department for International Trade as exporting is great champions. So what is graphene exactly? At just an atom thick, graphene is incredibly strong. Besides its super strength, it is ultra thin. Graphene is also extremely lightweight, flexible, and transparent. Graphene is an excellent conductor of heat and electricity too. What's more, Versarien's materials are the best available in the market. This is demonstrated through extensive independent testing. Versarien has already worked with a stellar list of groundbreaking companies on projects using our innovative graphene solutions, from solutions in automotive, rail and aerospace sectors to construction, engineering and clothing. From desalination, oil and gas and energy sectors to biomedical applications, miniature electronics devices and fast-moving consumer goods. Versarien continues to work with major collaboration partners to develop large-scale industrial deployment of high-purity, low-defect graphene materials. We look forward to helping you develop your next innovative product. Versarien PLC. Graphene changes the game. Versarien helps you win.
But that's the kind of journey that we're on, and what I'll try and do over the next 10 minutes or so is just to illustrate and explain some of the things that you saw in the video. We're a revenue generating business. 2020, these are all as of the last annual report and full results not so long ago. Our revenues are about 8.3 million. We have a EBITDA of about 0.6 million. A loss before tax, if you include all the share-based payments, depreciation and exceptional items, of 4.7 million. We've successfully raised 6 million gross in March 2020, and you'll have seen that through the timeline on the bottom that we've acquired or created a company every year since we floated in 2013 on AIM. Some of those businesses are traditional manufacturing businesses where we hope to use the technology. Some of those, as I explained or was explained in the video, are our development companies, 2D Tech from the University of Manchester, Cambridge Graphene from the University of Cambridge, and a company based in Spain called Nanomat, who are looking at using the graphenes that we produce in energy applications such as batteries and supercapacitors. and we've seen some great results across the group more recently. Last year, we started our exploitation in terms of global expansion, and we're now operating in South Korea, in China, in the US, and we also have activity going on with the help of the UK government through the Department of International Trade in India and Malaysia and so on. 2020 was a difficult year for everybody, lots of challenges, but in this year, not only did we do a successful fundraising, we also were awarded a £5 million loan from Innovate UK for the graphene scale-up, the largest one that we believe to have been ever awarded. They're normally in the region of about £1 million. And more recently, in fact, since this presentation has been written, we've been awarded a contract with DSTL for £2 million to exploit graphene in defense applications. We talked a little bit in the video about the primary functions of graphene, it being extremely strong, it conducts heat, it's very, very good at conducting electricity, but there are also a number of secondary products that we're currently using as well. Antibacterial, antiviral, flame retardancy, anti-corrosion are all ancillary things that come along with the exploitation of graphene. And sometimes when you're looking at using graphene in a particular application, what you'll find is, although it'll achieve the primary consideration, which might be strength or flexibility, elongation, we actually find that we develop other benefits which are of great use to the customer. This can be in terms of flame retardancy, for instance, in aircraft parts that are made using composites. But there's a number of other kind of ancillary benefits to using graphene. Talk a little bit more about the focus the business is currently under, and the exploitation plan that we have is very aligned to the Innovate Award, the £5 million that was granted by Innovate UK, and it's split into 6 different areas. We're scaling up the graphene manufacturing using our 2 primary processes that we've developed. One of those creates graphene nanoplatelets, which are used in things like carbon fiber composites and plastics. The other patent is in conjunction with the University of Cambridge and creates graphene inks, which are used in things like printable electronics, textiles, and other areas in which you require a solution rather than necessarily a solid platelet. The 5 commercial focus areas, seat is around thermoset plastics. So these are the kinds of things that are found in carbon fiber composite products for automotive, aerospace and rail, where there's a big drive in all of those markets to try to reduce weight. Concrete is really about the use of graphene in construction. Arch is around polymers and what we call thermoplastics. Those are things like packaging, and 3D printing is a great use of that technology. L is around leisure and textiles and using our technologies in sports goods, sports clothing, and more recently in lots of other types of clothing where you need to improve the physical properties of either the yarns or the garments themselves. E is around elastomers, and that's the fancy name for things like the seals that we find in the oil and gas industry or in tires. And as we adopt electric vehicles, that puts more pressure onto more conventional technologies. I need to speed up a little bit here. We've detailed a number of collaborations that we're currently working on, which are focused around G-scale, but there's an awful lot more. These are where we're working with very large global blue chip companies where they're trying to use graphene. Any big global company will want a material which is reliable and repeatable, where the results are independently checked, and that's what we're doing. These companies, they can be sometimes quite secretive, but we've been able to name a few of them, including the Coates Group, which are involved in that textile part of the project that I spoke about earlier. More recently, we also spoke about some new technology we're developing with the University of Manchester. The University of Manchester is still a shareholder in the subsidiary and also in the overall umbrella company, the PLC, as is the University of Cambridge. So we have a very unique relationship with both universities, and that's a very unique relationship as well in terms of having both of them on our portfolio. We with this particular case, we're developing some chemical vapor deposition coatings for the aircraft industry, and more specifically around electrical components as we move towards the electrification of the aircraft industry, as we're seeing in the automotive industry. But you can see from the collaborations that we're doing everything from construction to shoes, from medical to aerospace, and so there's a wide variety of de-risking that's gone on, while still remaining very focused on those kind of 5 key areas. It's just a few slides just to explain what I've already talked about, but you can see how the company is concentrating on these 5 specific areas. Just to kind of highlight some of the performance advantages. My background is a mechanical engineer. I've been involved in the automotive industry. I was involved in the F1 industry. We used to try to achieve tenths of a second on a lap, or we used to try to achieve fractions of a percentage for the aircraft industry. And what we're seeing in the testing of graphene in a lot of industrial applications is that we're seeing double-digit and very impressive gains. In this particular case, we've seen in initial testing with some of our collaboration partners in the construction field, up to 38% increase in the compressive strength of concrete. Now that is kind of groundbreaking and shows the potential for this type of technology if it is scaled up and continues to demonstrate that kind of performance in volume. And because we're able to demonstrate these test results that have been independently tested, we're starting to see a lot of companies coming to us. So our sales and marketing is very reactive to the market at the moment, and as we get bigger, it will become more proactive. And I'm hoping that 2021, provided the global economies continue to improve, that will be the year that we really start to promote this technology on a firm foundation of scientific fact results based on independent testing. I won't say much about Arch. One of the questions I get asked an awful lot of is, this is a very interesting technology, but where are we going to see it and how long is it going to take? Technology always takes a long time to make it from the laboratory to the production facilities. And in this particular case, I think that the leisure industry is going to be one of those that's moving very, very quickly. We can say that because we're already in possession of garments that have been produced using this technology, and some of our shareholders were lucky enough to buy some of those pre-production prototypes so that they can see the technology in anger. Those are going to be produced so that we can demonstrate and promote, as I just said, to an awful lot of sports goods companies that are very interested in our technology. We work with one of the largest producers of those garments, a company called MAS, NAS, and they're based in Sri Lanka, and they're producing for a lot of household names. So very interested to have them on board, and we've been working with them for a number of years to be able to take the technology, as I say, from the laboratory to the factory. Elastomers are another area in which we're seeing a huge amount of performance advantages of using graphene in the products. So, great idea in the laboratory. Let's have a look about how it actually works in practice. And you can see here some very, very impressive figures. Probably only those engineers in the audience will know what they are. But 100% modulus performance, it's a big increase in terms of the way that the rubber is in function. So that probably didn't make much sense there. It means that actually when you actually get to use these in the real world, you're almost getting a doubling of that strength or of that elongation or any of those properties that you're trying to chase. It's not the only project that we're currently involved in. So G-Scale is a big part of our current team's workload. But as well as the Rolls-Royce CVD project that I talked about, we're also involved in a big European graphene flagship. This was a big program that was put together by the European state in order to develop graphene. And in this particular case, we're working with Airbus to develop graphene as a de-icing solution and to take away some of the nasty chemicals that we see being sprayed at aircraft as we wait to take off, but also improve the performance and to improve the use of aircraft in harsh environments. It also maps across to actually being able to understand how those structures are actually performing as well, so we can also take data from what's happening. TDAP is a program put about by the APC, the Advanced Propulsion Center, and that's about using graphene in lightweighting for the automotive industry, and I talked about the MOD project. We've also started to see, as a result of COVID, a lot of interest in using graphene in face masks, and we launched our range of face masks maybe 3 months ago now, and I've been pleased with the sales of those things. So with about 5 minutes left to go, I'll just quickly whiz through that we're supported by all of these organizations through our advisory panel, but I'd be interested in your questions now if you have any questions for me.
There's had lots of questions, and they might jump around a little bit from subject to subject, but if we can try and get through as many as we can, that would be great. So first up, how big is the market for graphene, and how much as a percentage do you have, and what is a realistic target?
Okay, so there's a wide variety of marketing reports out there. Everybody seems to be involved in generating reports to tell you how big the market is now or it's going to be in the future. The real answer is that the market for true graphene at the moment is relatively small because we're at the very early stages of this technology. So it's probably, you know, can be measured in weight or in volume as, you know, 10, 15, 100 tons. The reality is that everybody is under pressure to develop that capacity, and so there are a lot of quite scary figures about how much graphene we'll need in 5 or 10 years' time, and the big pressure is around the technical challenges of creating that capacity, and that's why the government have stepped in here and provided the capital to enable us to actually take on that challenge, and we've been actively involved in that for a few months now.
What industry accounts for most of Versarien sales?
So our business is split into 2 different parts. We have the more conventional manufacturing side, which provides all of the revenue at the moment. The development companies, the graphene is just starting off. We've had some good sales of products like the face masks, and we've announced those. And so at the moment, automotive is a big player within our portfolio, as is oil and gas and aerospace. So as we move forward, that will be joined, we think, in the first case by some consumer products like the face masks and an audio and leisure, but then that will develop into these other bigger industries as they go through their testing regimes.
Okay, next up, when do you expect to get a product out with graphene wear in it?
So graphene wear is a new brand that we've developed using this this technology that we've developed with MAS, and the first 75 were actually sold last month. They sold out in less than 20 minutes, and the reason we did that is we always like our shareholders to be part of our journey. It's very exciting to see a new product, something which has never been seen before. There are pre-production prototypes, and as next year develops, we're hoping that we'll have more people expressing interest in using our graphene wear or our nanine or any of the brands that we're currently developing in their clothing ranges. So those are conversations that are going on now. Unfortunately, the company is not in charge of the testing regime. That's always down to the customer, and things like development cycles and fashion entry points always play a part.
Okay, and Neill, one area you're focusing on is concrete. What advantage does your high quality graphene deliver in this application that your competitors' lower quality graphene cannot?
Well, we're not, although we've tested everybody's graphene out there in the course of our business, we're not in any way expressing any any view on other people's graphene. The true definition of graphene is a single layer of carbon atoms, and that can only be produced in one way, which is through this synthetic chemical vapor deposition. That's all a bit techy, but basically we take gas and we break it down into carbon. And then above that we have a few layer graphene, and then above that we kind of have the graphites of the world. Making true graphene is extremely difficult and can be quite expensive at the moment. But as the volume increases, that cost comes down and it becomes very interesting to our end customers. So we're very much set on creating the capacity and then finding the demand for it, because we've been awarded this loan by Innovate UK. So there's no doubt that the team is under pressure to develop ways in which it can produce high quality graphene in high volume to satisfy the requirements. What we do know is the better the quality of graphene, the closer it is to the physical properties that are exhibited by true graphene, which is a single layer thick.
Okay, what were your annual sales of graphene for the last 3 years, and are there any forecasts for the next year?
We don't do forecasts because that'll get us all in a lot of trouble. I don't know about you, Roland, but I would quite like to see my kids for Christmas. So we're not in a position to give you forecasts. In terms of the sales, they've been relatively low. We've had a couple of big orders which have skewed the development, but we're seeing more traction now with products like the masks and the other consumer goods I spoke about earlier. So really low, as you would expect, and building. So we're hopeful that trend will continue.
Okay, congrats on the MOD sale for using graphene in masks. Are there plans to scale this production and offer it for wider use cases such as public sector and other military organizations globally?
Could you just repeat that, Roland, because I'm not quite sure I got it all.
Okay, it says congrats on the MOD sale for using graphene in masks. Are there plans to scale this production and offer it for wider use cases such as public sector and other military organizations?
So there's a little bit of confusion there, which I hope to correct. So masks are one thing that have been developed with our Chinese partner, and who's an expert in the production and technology around masks. The MOD contract was around military applications, which do not include masks at this stage, but include other applications of graphene. So we will be working with the government to be able to showcase this technology at a variety of different events and opportunities.
Okay, so I had a good one here. But it's about focus and profitability. With so many different things happening, so many opportunities, so many things looking interesting, how do you narrow down and focus in to getting to profitability?
So, I mean, we could be profitable if we chose to cut off some of our development costs. You'll see that our EBITDA is actually quite close to break even. But to answer the question of that, you'll see that the G-Scale is very focused around those 5 areas. Within that, there are a lot of projects that use the same technology or the same fundamentals or foundations. So we're very focused around those 5 areas: thermosets, thermoplastics, construction, aerospace, and elastomers. So we have to remain focused. We're a relatively small team. There are lots of opportunities being presented in lots of different sectors, and we have to have a very good way of being able to filter those down to the ones that are going to get to profitability quickest and have the biggest market share.
A couple of questions about the share register. First up, who are the biggest shareholders? Different person has asked whether any of the universities you've mentioned have any share ownership too. So
both the University of Manchester and the University of Cambridge have shares, I believe, still in the PLC. They also definitely have shares in the subsidiary, the subsidiaries that relate to the universities. So Cambridge Graphene and the University of Cambridge and the University of Manchester with 2D Tech. So we own a majority stake in both of 85%, with the university holding 15%. And then in terms of the shareholder register, I'm actually the largest shareholder as it stands at the moment, and Lancaster Capital are the second largest shareholder. And then we have a variety of different institutions and private investors who have supported us either from day one or from more recently.
Okay, and I think on to the last question here, and again, it's a kind of double question. How many people does the firm employ, and are you keeping jobs in the UK?
With the support from the UK government, obviously one of the things that they're very conscious of and very supportive of is creating jobs in the UK. And we have no intention of moving our emphasis or focus away from the UK. We believe that the UK can be very strong in this area. It can lead another industrial revolution in this two-dimensional science, and we want to play our part in that. And the UK government believes that as well, and that's why they're being so supportive. And I can't say enough good words about the people that we've been dealing with within government that have actually made some of these things happen. And I've forgotten the other part of the question, Roland. What was the other part?
And it's how many do you employ? Did you answer that?
It's circa 100 people. So we're recruiting, and our business is morphing slightly in terms of the amount of focus that's on R&D and making some changes in that area to build that team to take on some of these opportunities. And we're able to do that again as a result of the government funding. So that's been really key in us driving forward through a very difficult period for everybody, but the team has worked incredibly hard. We've only lost a couple of days throughout the whole year to COVID, when we had to reorganize the factories, and we were trying to just get ourselves making sure that we abided by everything and everything was in place. We've done our part for society in terms of providing stuff for COVID, everything from bed panels for the Nightingales through to the masks and the PPE and the rest of the parts that have been required. And we're there to support getting out of this situation that the country finds itself in at the moment, and we want to play our part in that, and we're prepared and ready for that.
Lovely. All right, Neill. Thank you very much indeed for coming and presenting for us tonight.
No problem. Thank you very much for the opportunity.